Thank you very much for clicking on this video. I welcome you to chemical combination series. Before we start, I want us to first look at the word chemical combination. Here I changed the word chemical combination to refer to particles combination, because anytime you hear the word chemical serving as an adjective, you can always replace it with the word particles. The particles can be atom, although not all atom can exist on its own. Those atoms that can exist on their own, we call them molecules. So because of this, we have the chemical combination to be defined as coming together of atoms or coming together of molecules under attractive forces. So let's look at this. If for instance is coming together of atoms, we will render it as interatomic. If it is coming together of molecules, we will render it as intermolecular. Now atoms, they have reason why they come together. The major reason why atoms may come together is one, to be stable as molecule. You know, not all atoms can exist on their own. Just like hydrogen, fluorine, oxygen, nitrogen, chlorine, bromine, iodine might not be able to exist on their own as a single atom per element, but if they come together with other atoms of the same element, they can form molecule. So that is one of the reasons. The second reason is to attain stable electron configuration. Let's look at what electron configuration is. Whenever we are sharing electron around the nucleus of an atom, we are doing what we call electron configuration, and we follow rules in doing that. The image you are seeing here, Ne represents the symbol, and we have atomic weight, we have atomic number, and we have electron configuration. I want you to know that the atomic number is the total number of proton in the nucleus of an atom. An electron configuration, as you can see, must be equal to the atomic number if the atom is neutral. But if the electron configuration is not equal, then it becomes a charge. Hope you get me on that. So it becomes an ion. Okay, now let's look at the first 20 elements periodic table. If you look at hydrogen, lithium, sodium, potassium, the last value in the electron configuration is 1111. That of beryllium, magnesium, calcium is 222. Let's go to fluorine. Chlorine is 77. So that last values we are seeing 1111 or 7777. We call them valence electron number. Let me tell you what it can be referred to. For instance, a bus says that for us to move from one point to another, we must have 8 number of passengers. So when we have 1, we are not yet satisfied. When we have 2, we are not yet satisfied. When we have 3, we are not yet satisfied. When we have 4, we are not yet satisfied until we have that particular number 8. So we are satisfied. We can call it stable and we can move. That is how it can be referred to. So that is what happened in electrons. Until that number of electron is 8 at the atom shell, it is not yet stable. So because of this, we can say that these noble gases, they show what we call no valence electron. What we mean by valence electron, they are no longer waiting for passengers in the idea of passengers. So they are no longer waiting for electrons. So because of that, we say they are stable electron configuration. And also, there is no need for them to bond with other atoms. Okay. So other atoms want to be like these noble gases, and how they do that is by giving out all their valence electrons, then becomes a positive ion with charge number that is corresponding to that valence electrons. What I am trying to put over here is that those valence electron number that are below 4, something like 1, 2, 3, they are capable of releasing all their valence electrons, and when they do that, they will have shortage of electrons, shortage of negatively charged. And when someone is having shortage of negatively charged, you are increasing in positivity. So that means that if you give out 1 valence electron, you are going to be +1. If you give out 2 valence electrons, you are going to be +2. If you give out 3 valence electrons, you are going to be +3. Accepting a certain number of electron by an atom because you want to attain is stable electron configuration. Yeah, if they accept only 1 electron, they will be -1. If they accept only 2 electrons, they will become -2. If they accept only 3 electrons, they become -3. This is because when you accept 1 more electron, it means that you are having more electronegative, or you are having more negativity than positivity. I hope you get me on that. Some atoms may not be able to accept electron, but they really want to accept, but they couldn't be able to see atom that will give them the electron, but they can share with one another. And when they are sharing, they are specific. That number of electron you are to share to those atoms must be able to help those atoms to attain their stable electron configuration. So that is what we see in sharing. I want you to know that because of this idea, we group atoms into metal atoms and reactive non-metal atoms. For us to say it is a metal, it means that it is capable of releasing all its valence electron. And when this is done, it will become positive ion. Something like lithium, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, copper, mercury, silver, gold, and platinum. Although those ones that accept electron, we can call them reactive non-metal. Something like hydrogen, fluorine, oxygen, nitrogen, chlorine, bromine, iodine, phosphorus, sulfur, and chlorine. Mind you, hydrogen is capable of releasing electron, but when you release electron, it will not look like any of the noble gases. Rather, it will become a proton. So that's what disqualifies hydrogen from being a metal. So it is also possible that those non-metal can share electron with one another. So those ones that does that are also rendered as non-metals. Thank you very much for watching this video to this extent. I am so much excited to have you. I say a big thank you to you. Wait for me on the next episode, metallic bonding.